Hey everyone, so in the last video what we did was we understood what was VLAN. Then we understood what are the different types of VLAN. We understood how do we configure those VLANs on a Cisco switch. And then we understood how to debug them. But that's not enough. To understand is one thing, but to practically do it is another thing. So today what we are going to be doing is I have created a practical example for you guys. And what we are going to be doing is we are going to be configuring those VLANs practically in an environment. So it will be emulating an enterprise environment so that you understand what is happening and how do you debug in a real life scenario. So let's get into it. But before we do, please do press the like button and please do subscribe to my channel to get the latest updates. Now without any more delays, let's get into it. So this is an example that I have created for you to work on. Apparently I'll give you just a walkthrough of what the example is. So we have two buildings, building 1 on the left which is in yellow color, and building 2 on the right which is in blue color, and both the buildings have a separate student and teacher network. So student 1 refers to building 1, teacher 1 refers to building 1, and similarly student 2 and teacher 2 refer to building 2. And what we have in bottom is some laptops and IP phone. So the laptops marked with S are for students, and S-1 is student 1 network, and T-1 is teacher network. So this is student 1 laptop, and this is student 1 laptop again, and this is teacher 1, teacher 2, and this is teacher 1 and teacher 1 laptop, and teacher 1. The third laptop is also teacher 1. Similarly, on the right we have some student laptops and some teacher laptops. So let's get into the task. Before we get into the task, this file from Packet Tracer is available unconfigured on my GitHub. The link for that is in the description below. So you can download it and do it, and these are the tasks that we need to do, and these tasks are also listed there in the description below in the GitHub repository. And you can do all of these tasks, pause the video here and do all of these tasks on your own, or you can do these tasks one by one as we go along in this video. You can certainly skip some part of this video because I'm going to be listing task 1, task 2, task 3 and the other tasks as well as separate chapters. So you can skip and go to the task that you are facing a problem in. So let's start with the first task, and the first task states that all the devices are not on right now. Explore Packet Tracer and switch on all the devices. So we see that there are some devices which are not on, or the links are for which are not working, and specifically this is the device for which none of the links are working. This access switch seems to be on. We see a command line coming, but when we go into the command line, the device must be powered on. So if you remember the Packet Tracer tutorial that I did, some devices in Packet Tracer need power supply to be switched on. So let's plug in the power supply from here, and the switch is going on right now. So till the time the switch goes on, let's go back to our task. And the second task that we need to do is the network on the left is of student 1 and teacher 1, and we need to pass VLANs for the same from the server to the access switch such that student gets port 1 to 5 and teachers get port 6 to 10. So student 1s have VLAN 11 and teacher 1 have VLAN 12. So what we essentially need to do is we need to pass a VLAN from this switch, this 3650 multi-layer switch on the top, to the building 3650 multi-layer switch, and then down to the access layer switch, such that students on this side of the building or this side of the network on building 1 are able to access this server. And what we see is that the server does not has an IP address. This switch has gone on now. So let's start by configuring VLANs, then we'll look into the IP addressing also. So if you hover your mouse over the link you'll be able to see the interface that they are connected on. This is connected on gig 101 for student server 1, so gig 1/0/1, and the teacher 1 server is connected on gig 1/0/2. So let's open this switch. I'll move this a bit here. No, we do not want to enter the initial configuration. Press enter. Let's get into enable mode. So configuration T. So I'm using shortcut commands like en for enable and conf for configuration and just the T for terminal. As a starter, you should probably use the full command, that is enable configuration terminal. Don't use the shortcuts because they will only confuse you. Once you get the hang of it, you can use shortcut methods that I am using. So first let's configure VLAN 11 and let's name it student 1. Then next let's configure VLAN 12, that is for name teacher 1. The next thing that we need to do is enter interface gigabit Ethernet 1/0/1. That is the interface that the student 1 server is on, and let's make that switch port mode access, and let's also give it a description that's connected to student 1 server. And for switch port access VLAN 11. So from inside the configuration command, you can use the word do and then do a show VLAN brief, and what we get is that student 11 is configured, student 1 is configured on VLAN 11 and teacher 1 is configured on VLAN 12. The student 1 has an access switch on gig 1/0/1. So this do command, if you do just show from inside the configuration, you will get an error which is an unknown or an invalid input detected. But to do a show from inside configuration, what you need to append is do in front of the show command, which is very helpful when you are inside the configuration and you just want to see the configuration that you have done. So similarly, let's go into interface gigabit Ethernet 1/0/2. Description for this is, so let's not put this, let's use the arrow keys here and reuse this, and we just need to change the student to teacher here. So description is connected to teacher 1 server, and again we can use just arrow keys, switch port mode access, and then switch port access VLAN 12. Perfect. Let's do a show command again, and now we have gig 102 on VLAN 12. Perfect. So the next thing that we need to do is we need to pass this VLANs from this switch on the top to the building 3650. So let's see which port are they connected on, and they are connected on gig 1/0/23 from this top switch. So let's enter interface gigabit Ethernet 1/0/23, and let's put a description to building 1, and let's do a switch port mode trunk here. So this is going to be a trunk mode because we are going to be passing multiple VLANs, and we get an error which says that command rejected, an interface whose trunk encapsulation is auto cannot be configured to trunk mode. So this is okay because what we need to do is we need to define the encapsulation manually. We cannot leave it on auto and define it as trunk. We need to define it as .1q or ISL. So switch port trunk encapsulation, and we want to define it as .1q. Now if we do the command switch port mode trunk, we get no error the link goes down and then comes up back again. And next thing we do is switch port allowed VLANs, and we need to pass VLAN 11 and 12. So right now you are not using the word add here because, or remove or something like that, because we just need to pass two VLANs 11 and 12 to this switch, right? Later on when we need to append more VLANs, we'll use the command add also. So let's configure, let's do a write here and save all the configuration. And next thing, so let's do a show interface gigabit Ethernet 1/0/23 switch port, and we see that there are two VLANs that are trunking here, VLAN 11 and 12. The administrative mode is trunk, operational mode is trunk. We are doing encapsulation .1q. The negotiation on trunking is on. We can use the command show VLAN trunk also, but in packet tracer this command is not available. Had this command been available, we would have seen all the trunk VLANs easily. But anyways, we have a workaround. We know that we can use command show interface gigabit Ethernet 1/0/23 switch port also. So you need to know this, that you can use alternate commands also in case these commands are not available for any reasons, whether it's an old iOS, that's an old operating system of Cisco, or you are working in an environment where this command is just not available for any reason whatsoever. So the trunk is available till here now. So what we need to further do is trunk VLAN 11 and 12 to this switch and trunk VLAN 11 and 12 to this switch. So these two switches are connected on gig 101 and gig 102. So enable configuration terminal, and let's define VLANs on this switch also. So VLAN 11 is again named student 1 and VLAN 12 is named teacher 1. So VTP is used exactly for this reason. So what we are going to be essentially doing is define the same VLANs on one switch, then another, then another. So three layers and 4 switches. So this switch here, then this switch here, then this switch here, and this switch here. We are going to be defining the same VLANs again and again. Had VTP been enabled, every switch would have got this information. The moment we would have configured it here, all these switches down below would have got this information, or we would have configured a VLAN here, all these switches would have gotten this information. But since VTP is not enabled right now, we need to define VLANs in each and every switch. So that's fine. So interface, first what we need to do is we need to enable trunking on from the main switch. So gigabit 101/0/24. So interface gig 1/0/24, and again switch port trunk encapsulation .1q. So first we need to do is a switch port trunk encapsulation, then we need to do a switch port mode trunk, and the last thing we need is switch port trunk allowed VLAN 11,12. Now for the next two interfaces, what we can probably do is interface range gigabit 1/0/1 and 2. So now we are going to be defining the same set of configuration for both these interfaces. So let's do a description first. We forgot to put a description for the earlier port, we'll do it later. Description to access switches. So because we are defining a single configuration, so we can just write 2 access switches, but not to access switch 1 or access switch 2, because whatever we're going to define is going to be defined for both the interfaces. We'll change it later for each port separately. And let's do switch port trunk encapsulation .1q and switch port mode trunk, switch port trunk allowed VLANs 11,12. So now we have configured both the switches simultaneously. You see that both the ports have gone down, and now they have come up, and they are orange right now. There is a lot of time that sometimes these switches take. That's because of HTTP convergence happening. We'll understand this in the next lesson that we are going to be doing, and we're going to do a lab on that all as well. Let's concentrate on this first, and let's save this configuration. And okay, let's also input the proper descriptions for each of the ports. So description from a main switch and interface gig 1/0/1, description to access switch 1 and interface 1/0/2, description to access switch 2. Okay, so that will not cause any problem in the linkages. Next thing, let's do a show VLAN brief, and we have both the VLANs configured. Next, let's do a show interface gigabit 1/0/24 switch port, and we see that trunking is enabled on VLAN 11 and 12. Let's do it for gig 1/0/1. Trunking is enabled, and let's reconfirm it for 1/0/2 also. So trunking is enabled. Perfect. So now we have configured trunking till 3650 on building 1, and what we need to do next is enable trunking on the incoming ports are 2960, and then we need to link up all the clients that we have here. So the interface that this building 1 access switch 1 is linked on is gig 01. So let's go on the command line interface and enable configure T, and in this let's go to gig 01. So now this is a different switch, so you see that the interface is a bit different. It's not 1/0/1, it's 0/1. So in different switches it will be different port slots and the internet interface, so be careful. The best way to go is you can just do a show interface status and you'll see all the ports that are available on that particular switch. So on this switch there are fast Ethernet ports, but on the earlier switch they were all gigabit Ethernet ports. So be careful about this thing. Don't make a mistake about this. We are in gigabit 01, and let's put a description on this interface. The description is coming from building 1 main switch, and the switch port mode is trunk. Now in this switch, if you see that we just did the switch port mode trunk, and we did not get an error that the encapsulation is auto, something like this. So different switches, different IOSs will return different errors or will behave differently. Don't worry about it. It's okay. And it might be the case that if you have a newer 2960 or with a newer version of 2960, the newer iOS, that's it, you might get an error which says that you need to disable auto encapsulation mode first. So you can do a switch port trunk encap .1q or ISL, whatever you want, like we did earlier. So switch port trunk allowed VLAN 11 and 12. So that's it. That should do it for the trunk, and we see the switch port going down, and it's doing the HTTP part for the VLANs. It's okay. So let's go back into our task and let's see this task 2 once again. So what we have done till now is we have been able to get this VLANs to the access switch part, but what we need to do further is on the access switch we need to configure port 1 to 5 for students, 6 to 10 for teacher. So in this what we need to do is interface 1 to 5. So fast Ethernet 1 2 3 4 5 is for students. So interface range fast Ethernet 1, so 0/1 to 5, and we are in the interface range. So description students. So in this case, it's just students. We are not going to be allocating it to a specific student. Any student can come in and plug in their laptops on Ethernet 125 and they'll get the access. So switch port mode access and switch port access VLAN 11. Oh, sorry for the spellings. So switch port access VLAN 11, and we did not create a VLAN 11, it's created. Let's create a description of that also. So name is student 1 and VLAN 12 is name is teacher. So done. Next, let's do an interface range fast Ethernet 6 to 10, and this will be description teacher and switch port mode access butterfingers switch port access VLAN 12. So in 2960 what we have done is in access switch 1 we have trunked all the VLANs, that is 11 and 12, which were coming from the main switch, and we have created access ports on 1 to 5 for students and 6 to 10 for teachers. So next thing let's do is let's save this configuration for this switch. Let's write it, okay, and let's just reconfirm it once. So show VLAN brief, and we see that student VLAN 11 is for fast Ethernet 1 2 3 4 5 and teacher is for 6 7 8 9 10. And let's reconfirm if our trunking is also coming. So show interface gigabit Ethernet 0/1 switch port, and we see that the trunking is enabled, and we see the trunk also here. So great. So next thing, let's configure the other switch, also the access switch 2, and then we'll start linking up our clients. It's the same configuration. I'll just pause the video here and quickly do the configuration at my end. Okay, so welcome back, and I've done the configuration for access switch 2 as well. Made this as the trunk port, that is the port that is coming from the multi-layer switch, the building multi-layer switch, and then assigning port numbers 0 to 5, 1 to 5 and 6 to 10 respectively for student 1 and teacher 1. Done. So now what we need to do is we need to connect each of these endpoint clients to the devices. So what we need to do is we need to use a straight through cable and link up student to port number 1 to 5, any of the ports, and we need to link up teacher to a port at 6 7 8 9 10. So if you are doing all the configuration correctly, what you're going to be getting is on student you will get an IP address of 192.168.xy.0/24. That means student will get an IP address of 192.168.11 and teacher will get an IP address of 192.168.12. So if you hover your mouse over it, right now there is no IP address coming here. The link is up, but if we see the server is getting an IP address. Yeah, server is getting an IP address of 11.2, but student is not getting an IP address right now. So let's link up all the devices and see where we had gone wrong. So in the student laptops, if we see the fast Ethernet configuration is set to static, let's do a DHCP and also the DNS, and yes, we see the IP address is now assigned. We need to do it, I think, for all the devices here. So let's put DHCP here also, and we see that the IP addresses are getting assigned now to all the devices. So our configuration in the switches were all good, but the configuration at the endpoint device may not have been good, or we just didn't know it was the default configuration that we need to assign a static IP. So we see that the student is getting an IP now 192.168.11.3. Teacher is getting an IP address of 192.168.12 CDs, again 12 CDs, and student is getting an IP address of 11 series, and the teacher is getting an IP address of 12 series. So everything looks good. Even the servers are getting an IP address now. If you see this site server still don't have an IP address. They are linked to a fallback IP of 169.254.218. That's okay, because we have not configured the right hand side of our network. So just to check one thing, what we can do is we can just plug out this cable from student, and let's plug in this cable at port number 9. So if you remember that port number 6, 7, 8, 9, 10 are assigned to teacher. So what the student should now get is an IP address from a teacher series, that is 192.168.12 series. Let's hover our mouse over this device and see what happens. So it's still orange here. That means that the STP convergence is still happening. It's turned green now, and the IP address is not yet assigned for some reason. Let's wait for some little more time. Okay, so the student laptop has got an IP address from the teacher series, which is wrong. So to debug this, let's start checking up. So the first thing that we need to check up is where this link is linked up to. So we see that the link is linked to FA0/9, which is a port that we had said that we will assign to teacher. So what we need to do is, let's click here and change the port to fast Ethernet 0, 1, 2, 3, 4, 5. Any of these ports will do, because all of these ports are assigned to students. So whenever you get this problem and you are troubleshooting, even in an enterprise environment, start looking from at least one of the ends, and especially at the end where the problem is, start looking from there. Don't go directly here on this link, on the server link. That has no meaning whatsoever. Let's look at the direct link first, and if this link is okay, then look at the trunking here between the multi-layer switch of the building and the access switch that is having the problem, and then go up one level, because if it's working between multi-layer switch and the access switch 1, then it should work here also, because that means that the multi-layer switch 0 and 2 are properly linked up. So this is how the troubleshooting is also to be done in layer 2 network. So everything is working good here. What we need to do is we need to do a similar configuration here. What we can also do here on the right hand side is that we can do step number 3 in DTP. So step number 3 is do the same network as above for the second building. Only changes will be that student 2 to get VLAN 21 and teacher 2 to get VLAN 22. So we have already done task 4, that is we have got a correct IP addressing range in building 1. We need to configure our network for building 2. So in building 2, rather than doing a starting switch port mode access or switch port mode trunk, especially switch port mode trunk, let's do one thing. This time around, what we are going to do is we are going to make this whole network into a DTP. So what we are going to do is the ports that are directly linked to the server and to the endpoint devices, that is our laptops, we are going to define them as switch port mode access. But here what we are going to do is we are going to make this as an active port. We are going to make this as a passive port and this as an active mode. So this will try to link up here and request for a trunk. Similarly here also on these two ports, we are going to make this as a passive listening mode and these two as active talking mode. So let's get on to it and let's start doing this configuration now. So in this case, the teacher network is linked on gig 104 and the student network is linked on, it's hidden behind the, I think it's 103. Yeah, it should be 103. So let's enter the switch. So configuration T. So remember now that this switch is already working and this switch is working for your building 1, and any changes that you'll do on any of the links on building 1 is going to affect the network on building 1. So you don't want that to happen. So this is kind of a production environment for you, right? So be careful now. So this is 103 and 104. So the first thing that we need to do is we need to give 2 more VLANs, VLAN 21 and VLAN 22. So let's define 2 VLANs now. VLAN 21, let's name it. So we should name it student 2, and then VLAN 22, name it teacher 2, and on interface gig 103, description, connect it to student to server, switch port mode access, switch port access VLAN 21, and similarly for interface gig 104, description will be connected to teacher to server, and switch port mode access, switch port access VLAN 12. Let's do a do show VLAN brief here, and let's confirm if we have the right set of, so let's check if we have the right set of interfaces linked to the right set of VLANs. We see that VLAN 21 is linked to gig 103, but VLAN 20, so gig 104 is still not here. Let's do a refresh. So we see a mistake that the gig 104 has been linked to VLAN 12. So the command that we entered was wrong. Let's change this immediately. We don't want a trouble to happen. So switch port and we'll access VLAN 22. Let's do a show again. Yes, this time around this is okay. So we did a mistake. So that is why you need to constantly use show command, so to check whether you have entered the right command or not. Right. So in Cisco switches, there's nothing known as commit. Whatever changes that you are doing are going live at the moment. So any wrong changes that you do are going to affect your network. So let's write this configuration on the switch right now, and let's see if these two servers have got an IP address. The student server has got an IP address, and the teacher server is still not up. So the teacher server also now has an IP address of the right subnet. What we need to do further is now make this as a DTP port. So what we need to do now is we need to trunk the port number 1024, that 1/0/24 on the master switch, but we are going to make this as a passive port, so it's going to be dynamic auto, but gig 1/0/24 on the building multi-layer switch is going to be dynamic desirable. So let's do these changes. First we are doing it for the master switch, that is the multi-layer switch which is controlling both the building switches. So configure T and interface gig 1/0/24, 1/0/24. What we are going to do is give it a description to building 2, and what we need to do is switch port mode dynamic, and we want to do it auto. So what we are doing is we are assigning a passive listening here, and switch port trunk allowed VLANs 11,12. And the second thing that we are doing is we are allowing VLAN 11 and 12 to traverse through here, right? So now this has gone again into HTTP thing. So this is okay. Let's write this configuration, and let's go into the next building multi-layer switch. Let's put this here. No, we don't want to enter. So enable configure terminal. So interface gigabit 1/0/24. Description is coming main link. Let's name it main link this time around. So now this is switch port mode dynamic. So this is going to be the active switch, so dynamic desirable, and switch port trunk allowed VLANs is going to be 11,12. So let's write this configuration. I'll open the other switch also. So let's open both the switch side by side now. So on the left is the main switch, and on the right is the multi-layer switch inside the building. So what we need to do is show interface. Both are linked up on the same interface 1024 switch port, and here also let's do a show interface gig 1/0/24 switch port. So here it's dynamic auto. Dynamic auto is when the switch is just listening but not actively initiating a trunking connection, but the dynamic desirable mode is when the switch is actively trying to do trunking, that is trying to initialize trunking. So what we also see is the operation mode now for both the ports is trunking, because the dynamic desirable here has contacted the other switch and told it wants to negotiate trunking. So perfect. Let's do one more thing on this building switch. What we need to do next is we need to, for both the access switches, get the ports on dynamic auto. That is again a passive listening mode. So if the switches want to do a trunking, they can negotiate it with the multi-access layer switch. So it's linked to gig 101 and let's have a look, gig 102. So let's enter the configuration mode, interface range gig 101 and 2. So the description that we are going to put here is that these are linked to access switches, and switch port mode is going to be dynamic okay, switch. So butterfingers again, switch port mode is going to be dynamic auto, and switch port trunk allowed VLANs is going to be 11 and 12. We are going to allow both VLAN 11 and 12. So we see that both the ports have gone into the HTTP convergence again. So let's write this configuration. So now that both these ports are dynamic auto, we need to make both these ports as dynamic desirable, which is coming from access switch 1 to the multi-layer switch on building 2. The port is gig 01, and similarly for access switch 2 on gig 01 linking to multi-layer switch on building 2. So let's open this switch and let's get down with the configuration of it. So enable configure T, so VLAN 11, this is going to be named as student 2, then VLAN, so we needed not to create VLAN 11, so this is a wrong configuration that we have done. So to undo this configuration, let's just do no VLAN 11. So when we do no VLAN, what is going to happen is it's going to erase the VLAN. So let's do a show VLAN brief, and we see that there is only VLAN 100 going on this switch, but there is no VLAN 100. Oh, there's no VLAN 11. So let's do a VLAN 21 this time, and this is going to be named as student 2, VLAN 22, name teacher 2. So interface gig 0/1. Now this is going to be description coming from building 2 multi-layer switch. Now switch port mode is going to be dynamic desirable. Here we are going to initiate a connection from this switch, and a switch port trunk we allowed VLANs is going to be 11 and 12. So now what we have done is the multi-layer switch has dynamic auto on the switches, on the links going to access switches, and the access switches are going to have dynamic desirable to the links going towards multi-layer switch. So let's write this configuration, and we need to also configure the interfaces fast Ethernet 0/1 to 5 for the students. So description is, so interface range, what we need to give, and a description is going to be students, and the switch port mode access, switch port access VLAN 21. So we are going to give them access on VLAN 21. Similarly, for interface range fast Ethernet 0/6 to 10, description is going to be teacher, and switch port mode access again, and switch port access VLAN 22. So this is done for this switch. Let's write this configuration. Let's verify this configuration once by doing a show command, show VLAN brief, and we see 21 and 22. So this is good. And what we also need to do is now link up these devices to the switch. So this is student, so this should be linked up to 1 to 5. This one is teacher, so this should link up to 6 to 10. Again, this is student, so let's link this up to port number 1 to 5. Now let's do a similar configuration here. I'm going to pause the video. You can do it on your own. We have already done it many times now, so this is not going to be much of a problem. Okay, welcome back. So the configuration is done. Let's link up the switches with the endpoint devices. This is the teacher, and the next one is the student. So let's link that up also. So by now this student should have got an IP address, which is not happening. So that means that there is some problem. We have done some wrong configuration, or the fast Ethernet is not accepting DHCP. Well, let's switch first this to DHCP, and let's wait for the devices to get an IP address from the network. So this is done. Student 21 is still not getting an IP address, so that means there is some issue. Let's get into this access switch and let's see what the issue could be. Or first let's wait for this, and here also the student is not getting an IP address. So let's see what the issue could be. Let's go into the show VLAN brief first and see that the VLAN 21, that is for the student, is fast Ethernet 0, 1, 2, 3, 4 and fast Ethernet 5. Let's make it a bit bigger so that we are readable. It's readable. And VLAN 22 is from fast Ethernet 06 to 010. This configuration is good. Let's check up the interface, show interface gigabit 01, which is our uplink trunk switch port. And so here is the first mistake that we have done. We have enabled trunking on VLAN 11 and 12, which should not have been done. So let's change this configuration. So configure T and interface gig 01, switch port trunk allowed VLANs 21 and 22. So this should be good now. Let's write this configuration. Let's do a show again, and we see the configuration is good now. So let's verify if the student's laptop is getting an IP address. No, the student laptop is still not getting an IP address. So the next thing that we can do is let's do a show MAC address table for VLAN. Okay, the VLAN command is not supported here, or is it dynamic? Let's just do a dynamic, and we see that we are getting an IP address. We are getting MAC addresses from VLAN 21 and 22 on the fast Ethernet, but we are not getting any MAC addresses from VLAN above. So let's open this switch, the main switch. Let's put it here. Let's put our access switch on the other side, and let's do one thing, and let's do a show MAC address table dynamic here. Okay, so we see that 21 and 22 we are getting from gig 1022, but we are not getting it from anywhere else. So MAC addresses have a timeout also, so let's consider that. That is where these servers are not showing up. Otherwise these server would not have got an IP address. Because these servers have an IP address, I assume that they have a perfect link. So gig 1022 is to the DHCP VoIP controller, and so we are not able to communicate through the switches below. So there is some problem. Let's verify it one by one. I think let's go from bottom up, and this configuration seems to be okay. Now let's access this switch, and let's do a show interface gigabit 1/0/1 switch port. Again, I see the problem that I have accidentally done trunking on 11 and 12. So configure T. I suppose this is the same problem going to be on gig 102, which is the other side also. Yes, same problem. So okay, so configure T, interface range, because I used the range command, so both the switches were misconfigured, both the interfaces were misconfigured. So switch port allowed, switch port trunk allowed VLANs is 21,22. This should be okay now. Let's confirm it on switch port. Yes, this is okay on this, and this is okay on port number gig 1001. Okay, so now the laptop should get a MAC address. Okay, the HTTP convergence is going on. We'll wait for it to end. Okay, so HTTP convergence has ended, and I think the laptop should now get an IP address. We'll wait for a moment, but I don't think so anything is happening. So let's do a show MAC address table here, dynamic, and let's see what's happening. And we are not getting any VLAN MAC addresses. We are only getting MAC addresses from VLAN 1. So what could be the reason? So let's do a show VLAN brief. Okay, so I see the problem here. We have not added VLANs 21 and 22 to database of this multi-layer switch on building 2. So earlier on, what was happening was when I was configuring an access port, the VLANs, if I had not configured, were getting automatically added to the database. But in this particular case, what is happening is that since we have made trunk, the VLANs are not getting added, and we need to add them manually. So let's do this. Configure T. So VLAN 21. Okay, VLAN 21. Name is student, and VLAN. Let's do it student 2, so that we don't get confused. VLAN 22 is name is teacher. So now the VLANs have been added to the database, and this should work now. I'll just write the configuration on the device, and let's see. So let's see if the MAC address table now comes up. Dynamic. So yes, I see a MAC address of 21. That is the student MAC address coming from gig 102. That is from building tool access switch 2. I had paused the video, and what I've done is I've accidentally added VLAN 11 and 12 everywhere, so which should not have been done. Anyways, I'll just rectify this mistake of mine. I'll pause the video again for a while now. So I had actually passed a VLAN 1, 11 and 12 even on the main switch, which should not have been done. I'm rectifying that right now. I'll pause the video again for a while. Okay, welcome back. So all the laptops have now got a proper IP that they should be getting. So apparently the problem was that I was passing the wrong VLANs all across the network. I was passing VLAN 11 and 12, whereas this side of the network was for only VLAN 21 and 22 as configured by us. That should have been configured by us. So this is the kind of problem that you can also face, and what you need to do is you need to start from bottom, that where the endpoint of the problem is. Don't go looking at the main source or the core of the problem, because the core of the network, because there will be a lot of links there, and you don't want to debug in a lot of link environment. You want to debug as close to the problem as possible. So to debug from bottom, that is from the endpoint of the problem, is going to be always going to be a good thing. So now we have done this task also, and all our laptops and server have got an IP address. So let's look at what is the next task. if all tasks are done correctly, the servers and student devices will get IP addresses where the XY is the VLAN ID. This task is done now. Now, in case there is a problem, try to debug the same from the switch using various show commands. We had to do this because we had several problems, so we were constantly doing this step, step number 5. Now, administrator on both the buildings will have common VLAN 100 and will have to be connected to the phones in the network. They will access ports 11 to 15 only. Once the phones are connected properly to the network, they should get IP address and a number with which they can dial each other. Note, provision for one phone in each building must be done. We have only 2 phones configured in our router. Okay, so this task is basically that there are the IP phones are for the administrators, and they are going to be using port number 11 to 15, and they are going to be using VLAN 100. So the VLAN 100 is apparently already been configured for us, and what we need to do is we need to just pass VLAN 100 again. And what we need is that we need to provision that both the switches, all the 4 switches have provision for accessing VLAN 100 on ports 11 to 15. So let's get into this switch and let's see if there is any configuration right now for VLAN 100. So show VLAN brief. So there is no configuration for VLAN 100. What I think is that we need to also link up this port. So port gig 1022 will have to be linked up. So let's get into the configuration and let's set the VLAN 100. So this is going to be our voice VLAN. So let's get into the interface gig 1022, which is going to be the main VoIP controller. So switch port, this is also already a trunk port, I guess. Let's confirm this. So do show interface gig 1022 switch port. So okay, so the VLAN is already being trunked from here. So we see that VLAN 11 to 12, 21 to 22 and 100 are already getting trunked. So we don't need to do anything in here. So let's do a show of the downstream link also, that is 23 and 24. So do show VLAN 23, port number 23, and we see only 11 and 12 is being trunked here, and on 24, that is building 2, we see only 21 and 22 going. So what we need to do is apparently we need to transfer VLAN 100 on this port that is going to building 1 and this port which is going to VLAN building number 2. So interface gig 1/0/23 and 24. Let's do it simultaneously. Interface range we need to use. So this time around we are not going to do switch port trunk allowed VLAN and directly name the VLAN. What we are going to use is the add command. So we are going to append VLAN 100 to both the sides. So let's do this and let's verify this once on port number 24. So we have appended VLAN 100. So we are not going to write allowed switch port trunk allowed VLAN 21, 22, 100. No, we are going to be just doing add VLAN 100. So similarly, let's show this for port number 23 also, and we have 11, 12 and 100. So similarly, let's do it for all the switches, downstream switches also. Let's do it for both the building switches and on the 2960. I'll pause the video, you can do it on your own. This is now a simple task. Okay, so I've configured it for all the switches. This is the last switch that I'm going to configure it. And so what we need to do is first we need to make this as trunk port for VLAN 100. So configure T. So on interface gigabit 0/1, what we need to do first is switch port trunk allowed VLAN add 100. So we are adding appending VLAN. Let's create VLAN 100 also, and let's name it as voice, and then on interface range fast Ethernet 011 to 15. What we want to do is description of admin slash voice, and a switch port mode is going to be access for the desktop, and switch port voice VLAN is 100. So what we are doing is we are configuring voice VLAN, and we are defining the port as access port, so in case any desktop is going to be hooked up, they can also connect. So now what we need to do is we need to connect this IP phone to this switch. So let's do this. So we are going to connect it from switch port, not the PC port, and we are going to link it to fast Ethernet 011 to 15, any of the ports. So we see this as red. So let's enter this IP phone, and we see that there is no power, so let's put a power adapter. So let's drag and drop it here, and now the IP phone is on. It's going to take some time to get the link up and then to get an IP address. So what I'll do is I'll pause the video till the time it gets an IP address. So finally the IP addresses have been assigned to the phones, and the phones have got the lines. Now I faced some problems while the line number was getting assigned. So in case you get that problem, don't worry about it. It should be just fine if you're getting an IP address. But if you get the line number, then you'll see that phone on the left is getting one line number and the phone on the right is getting another line number. So if you were to go here and click on the receiver here, you will actually be able to dial 4 3 zeros, 1 2 3, and then a 2 is the number on the left hand side. So if you see here now on the GUI, the phone is ringing and it's coming from 40,003, and if you pick up the receiver, both the phones are now connected to each other. So let's just disconnect it. So if you're able to do this, it's great. If not, don't worry, don't stress about it. If you're getting an IP address, that should be good enough. That is what you were assigned to do. Your VLAN should work. I hope that you enjoyed today's lesson. This was a lengthy video, but these kind of practicals you really get a hands-on until and unless you enter an enterprise. So this was just one of the scenarios that I was able to create for you. Do let me know in the comment section below if you would want more scenarios like this, so that I can do more work on these. So until we meet the next time, goodbye.